let's take a look at graphing the rational family of functions. Now, rational functions can also be called reciprocal or inverse functions depending on which algebra text you are looking at. So what I would like you to do first is to set up this table of values that I have on the left-hand side, and then pause the video while you figure out what 1 divided by x for each of these values is. For example, I'll do the first one. See that x equals -4, so 1 divided by x is going to be -1 divided by 4. Alright, pause the video now and finish filling in these values. Good. Check your values with mine. And I haven't done the last values, but let's graph these now. So when x is -4, y is -1/4. When x is -3, y is -1/3. And so on. Now, when x is -1, y is -1. And this point is going to be about the most useful point on this graph as far as graphing is concerned. Now, when x is -1/2, y is -2, and when x is -1/4, y is -4, and so on. So you see that the points are making this nice little curve. Now, if we do it with the positive values, let's mark our x-axis this way. The most important one, of course, is 1, 1, because everything else we're going to have to estimate. Now, as x is a fractional value, the reciprocal is going to get much bigger, so as x gets smaller, y gets really, really huge. And as x gets larger, y becomes much, much smaller, because the reciprocal of large numbers are going to be very small. Now, if I connect my dots here, what I get is my parent rational function, and these two things are called branches. These two the function is always going to have two parts, and these are called the branches. Alright, now when you go to graph these for class, it's important that you get this corner of the branch in the right spot. These are at 1, 1. Beyond that, it's a game of estimation. So if I see those points in the right spot, or if you can locate those points in the right spot on a graph, you can estimate very well what the graph would be without having to rely on, seeing perfectly where 1/4 might be. Now, notice the dotted lines getting drawn on the x and y axes. These are called asymptotes, and asymptotes are lines that the graph never touches. And in order to graph this type of function very accurately, it's awfully useful to have this nice T-shaped asymptotes drawn in the right spot. But for now, in the parent function, the asymptotes are on the x and y axes because those are the lines that the graph never touches.